Hello, good morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Ionic Equilibrium, and in this session we are going to learn about how to calculate the pH value of a given solution. Let's start the session, right? So here let us see. Whatever the volume of water is added, the pH of an acid is always less than 7. Okay, the meaning of that is, let us take a H2SO4 here. In this container, what did we take? A H2SO4. Now, you are adding water to it. Let us add, there is some 1 liter of H2SO4. You have added 10 liter water. 10 liter water. If you add 10 liter water, its concentration decreases. Can it be converted into base? Okay. Will its pH become equal to 7? Will its pH become equal to greater than 7? No. Its pH will be always less than 7. Compulsorily less than 7. A small quantity will be less than 7. So, whatever the amount of water you add to an acid solution, its pH will be always less than 7. So, pH will be always less than 7. Are you getting this? And for a base, it is always more than 7. We have studied and we know that for an acidic solution, pH will be less than 7. For a basic solution, the pH will be greater than 7. So let us take another beaker. Okay. In this, what do we have? We have, let us take NaOH. What is that? NaOH. No doubt it will be pH greater than 7. It is something like 1 liter water, 1 liter NaOH solution. Now you have added some 20 liter water. Will its pH will become equal to 7 or less than 7? No. Its pH will be always greater than 7. Okay. To an acidic solution, though you add a huge amount of water, huge volume of water, its pH will be always less than 7. Okay. For a basic solution, whatever the dilution you made to that basic solution, its pH will be always greater than 7. This you need to remember. Okay. So to show that we are solving some two problems, let us see here. Here what is given? pH value of 10 power minus 8 m HCl solution is given. And we know how to calculate pH. So simply if you calculate pH, pH is equal to, we know that minus log H plus N concentration. So if you solve it minus log H plus N concentration, you know that HCl dissociates H plus Cl minus. For a strong acid, so 10 power minus 8 m, H plus concentration will be 10 power minus 8 m. Okay, 1 mole of HCl gives you 1 mole of H plus. 10 power minus 8 moles gives you 10 power minus 8 moles of H plus. So what is H plus ion concentration now? It is equal to 10 power minus 8 molar. Then if I write here, if I substitute here 10 power minus 8 molar, then what we get? Minus of minus 8 log 10 base 10. That is equal to plus 8. Plus 8 means pH is greater than 7. So now what is this solution? HCl solution. Can HCl solution have pH is equal to 8? Is it possible? Is it possible? pH 8 means what is that solution? Basic solution. pH 8 means what is that solution? Basic solution. So this is not correct. What is this? This is not correct. This is wrong. Then how can you show that pH is less than 7? So it is a HCl solution. HCl solution means it is containing water also. So what is present here in this solution? You have what? HCl. Along with HCl you have water. HCl dissociates into H plus Cl minus. This is given 10 power minus atm. H plus will be 10 power minus atm. And we know that water is a weak electrolyte. It dissociates into H plus OH minus. And this is all calculated at 25 degrees centigrade. We have studied that H plus concentration is equal to 10 power minus 7 molar. Now these 10 power minus 8m and 10 power minus 7m are comparable. They are very closer. They are very closer. So that H plus ion concentration from water, contributed from water, is also taken. So total H plus ion concentration is equal to 10 power minus 8m, which is from HCl, plus 10 power minus 7m, this is from water. Okay, always from water we don't take. When it is comparable with the concentration of H plus, then we take. Let us see that also. That is equal to, now this I can write as a 10 power minus 8. Okay, how can I write it as 10 power minus 8m plus 10 into 10 power minus 8m. So this I can write as 10 power minus 8 in comma 1 plus 10 into 10 power minus 8m. That is equal to 11 into 10 power minus 8m. So we got what? H plus ion concentration. Then now we can calculate pH. So pH is equal to, we know that it is minus log H plus ion concentration. That is equal to minus log 11 into 10 power minus 8. Okay. So then what I can write? Log A into B is equal to log 11 plus log 10 power minus 8. That is equal to minus log 11 is equal to log 10 is equal to 1. So 1.04 plus, okay, log 10 power minus 8 is equal to minus 8 log 10. Okay, so minus 1.04 plus minus 8 log 10 is equal to 1. That is equal to minus 1.04 plus 8. So that is equal to 8 minus 1.04. That is equal to 6.96. What is that? Now is the pH less than 7 or greater than 7? The pH is less than 7. pH is less than 7. See here, pH is less than 7. What is that? 6.96. What answer did we get? 6.96. Understood? So how did we derive it? We have derived it by taking the H plus ion concentration contributed from water dissociation. Okay. Now let us see another problem. Here is that problem given. Calculate the pH value in 10 power minus 8m NaOH. 10 power minus 8m NaOH. Now let us see here. If you calculate generally, we know that NaOH gives rise to Na plus plus OH minus. 1 mole of NaOH gives you 1 mole of OH minus. Here if it is 10 power minus 8 molar, we know that 1 mole of NaOH gives you 1 mole of OH minus. So it gives how much? 10 power minus 8 m. If you calculate this, we know that POH is equal to minus log OH minus ion concentration, that is equal to minus log 10 power minus 8, that is equal to plus 8. Okay, I will use one more step here. So minus of minus 8, okay, log 10 base 10, that is equal to plus 8. So pH plus POH is equal to 14. pH is equal to 14 minus POH, that is equal to 14 minus 8, that is equal to 6. That is equal to 6. So will the pH of a basic solution, NaOH is base, it is base. Can the base has pH 6? What we have studied, its pH must not be 7 or less than 7. It must not be 7 or less than 7. Base. The pH of a base is always greater than 7. pH of a base is greater than 7. Now what did you find here? We have found that the pH of this base is less than 7. So it is not possible. This is not correct. Then how to solve it? Now here we have NaOH solution. What do we have? NaOH. So NaOH, along with NaOH, we do have water also. We do have water. So NaOH dissociates into Na plus plus OH minus. Here water dissociates into H plus plus OH minus. Already we have studied that from NaOH, OH minus contribution is 10 power minus 8. So total OH minus ion concentration is 10 power minus 8 m plus. This is from what? Whom? NaOH. We know that OH minus ion concentration at 25 degrees centigrade is 10 power minus 7 m. So where did we get from this 10 power minus 7? This 10 power minus 7 is from the dissociation of water. From water also we have OH minus. So this OH minus is from NaOH, this OH is from water dissociation. Then total OH minus ion concentration can be written as 10 power minus 8 plus 1 into 10 power minus 8, 10 into 10 power minus 8. Okay. So by taking common we get 11 into 10 power minus 8. What is this OH minus ion concentration? Now POH before we have calculated minus log OH minus ion concentration, which is equal to minus log 11 into 10 power minus 8. This can be written as 8 minus log 11, that is equal to 8 minus log 11 is equal to, before we have seen 0 point, that is equal to 6.96. What do we get? POH, and we know that pH plus POH is equal to 14, and pH is equal to what? 14 minus POH, that is equal to 14 minus 6.96, that is equal to 7.04. So did we get pH greater than 7 or 7 or less than 7? Greater than 7. See, answer will be 7.04. Understood? Understood? So whatever the amount of water you add to either acidic solution or basic solution, acidic solution remains as acid and its pH will be less than 7. Basic solution remains as base and its pH will be always greater than 7. Do you understand? So that's the thing. Okay, let us go with the next part. Let us see here. If an aqueous solution of an acid is diluted by 10 times, its pH of the solution increases by 1 unit. Okay. So, if the aqueous solution of acid is diluted by 10 times, let us take pH of a solution is equal to, let us take pH is equal to 2 molar. pH is equal to what? 2. pH is equal to 2. Then its H plus ion concentration will be, H plus ion concentration will be 10 power minus 2. You know that. If pH is equal to 2, its H plus will be equal to what? Its H plus will be equal to, H plus ion concentration is equal to 10 power minus pH, that is equal to 10 power minus 2 molar. Molar means here 10 power minus 2 moles per liter. Now what I am doing? I am diluting it by 10 times. That means what I am doing? Here H plus ion concentration I am diluting 10 power minus 2 moles per, here it is 1 liter. 10 times of 1 liter means 10 liter. I am making it 10 liters. I am making it 10 liters. So 10 times I am diluting it. So here I am having okay, a solution. For example, its pH is equal to 2. Its volume is 1 liter. I am adding 9 liters of water. That means final volume will be 10 liters. 10 times to that of 1 liter. 10 times is different. Times 1 liter, 10 liters. 10 liter is 10 times to that of 1 liter. 10 times it is diluted. Then what is the pH final? pH final, let it be initial. What will be pH final? Now let us calculate H plus ion concentration here. H plus ion concentration is equal to 10 power minus 2 by 10 gives you 10 power minus 3 moles per liter. So we have H plus ion concentration, then pH is equal to minus log 10 power minus 3, then that is equal to 3. So final pH is 3. See, if the aqueous solution of an acid is diluted by 10 times, 10 times if I am diluting, how much pH is increasing? pH is increased from 2 to 3. That means 1 unit. pH is increased by how many units? 1 unit. pH is increased by how many units? 1 unit. Understood? Understood? Simply here volume, this volume is changed to 10 liters. The same is asked next. Here you see, if it is diluted by 100 times, pH of the solution increases by 2 units. The same problem let us take but pH is equal to 2. That means H plus ion concentration is equal to 10 power minus 2 molar moles per liter, 1 liter. If what is done, H plus ion concentration 10 power minus 2 moles are there, it is diluted 100 times. 100 times means 100 liters. This what will it become? That it become 10 power minus 4 moles per liter. Then what will be final pH? This is initial pH. It is final pH after dilution. pH final is equal to minus log H plus ion concentration, that is equal to minus log 10 power minus 4, that is equal to 4. So when you dilute it by 100 times, the pH of the solution increases by how many units? 2 units. You see, initial pH is 2, final pH is 4. Okay, 2 units were increased. 2 units were increased. The same here, if it is diluted by 1000 times, pH of the solution increases by 3 units. 3 units. The same question, let us take pH is equal to 2, H plus ion concentration is equal to 10 power minus 2 moles per liter. Then here H plus ion concentration after dilution. Okay, after dilution, if I say this is before dilution, this is after dilution, 10 power minus 2 moles by how many liters? This is 1 liter. Here 1000 times, that means 1000 liters. That is equal to 10 power minus 2 moles. But I can write 10 power 2 by 1000 gives you how much? 10 power 5, 10 power minus 5 moles per liter. Now pH is equal to what you can write? Minus log 10 power minus 5, that is equal to plus 5. Okay, so pH is equal to plus 5. So 1000 times if I dilute the solution, the pH is increasing by, see, initial is 2, final is 5. That means how many units it has been increased? 3 units it has been increased. It has been increased 3 times. Understood? Okay. So now you are asked about a base. What is this? A base. Let us see in the case of a base. How does this pH change on diluting the base? Okay, here if you see, if the aqueous solution of a base is diluted by 10 times, what is this? 10 times you are diluting, then the pH of the solution decreases by 1 unit. In the case of acid, if you dilute an acid solution by 10 times, the pH increases by 1 unit. Here, if you dilute a basic solution by 10 times, the pH of the solution decreases by 1 unit. Are you getting this? So let us see. Here, basic solution, so pH is equal to, for example, let me take it as 9. For this solution, the corresponding POH will be equal to, POH is equal to 5. Why it is 5? Because pH plus POH at 25 degrees centigrade is equal to 14. 9 plus 5 is equal to what? 14. Then what is corresponding OH minus for this POH is equal to 5? Then that will be equal to 10 power minus 5 moles per 1 liter. Moles per liter means moles per 1 liter. This is before dilution. Let me take it as initial. Then after dilution, let me take it as final. Then that is equal to 10 power minus 5 moles per how many liters? Now you are diluting the basic solution by 10 times. 10 times means 10 liters. 10 liter is how many times to that of 1 liter? 10 times. So then OH minus ion concentration, final is equal to, then it will be equal to 10 power minus 6. Okay, moles per liter. Then now calculate POH. POH is equal to minus log OH minus ion concentration, that is equal to minus log 10 power minus 6, that is equal to plus 6. So what did you get? POH. Then convert it into pH. pH is equal to 14 minus POH, that is equal to 14 minus 6, that is equal to 8. pH final. So after dilution, the pH has become 8. Before dilution, the pH is 9. Are you finding decrease in the pH by 1 unit? Yes, there is a decrease in the pH by 1 unit. Got it? So let us see. For the same basic solution we are discussing. When you are diluting the solution by how many times? 100 times, the pH of the solution decreases by 2 units. How many units? 2 units. Let us see. So let us take pH is equal to 10. When pH is equal to 10, that is basic solution, right? When pH is equal to 10, that is basic solution. If a solution has pH greater than 7, then it will be basic solution. Okay. So now, what will be POH for this corresponding pH? That will be 4. And what will be the OH minus ion concentration to this corresponding POH? Then that will be equal to 10 power minus 4 moles per liter. Okay. Now this is initial OH minus concentration. Now OH minus ion concentration final I am taking. Final means, what is meaning of final here? After dilution. So then that is equal to 10 power minus 4 moles by, you are diluting it how many times? 100 times. That means 100 liters. 1 liter. Then OH minus ion concentration will be what? 10 power minus 6 moles per liter. OH minus ion. So this OH minus ion concentration, we have got OH minus ion concentration. When then we can calculate POH. Then POH is equal to what? Minus log OH minus ion concentration. Then that is equal to minus log 10 power minus 6, which is equal to plus 6. Then what will be pH for this? So pH is equal to 14 minus POH. Then that is equal to 14 minus POH is equal to 6. Then what did we get? Answer 8. Okay, so this is pH final, this is pH initial. Initial is 10, final is 8. How many units it has been decreased? 2 units it has been decreased. How many units are decreased? 2 units are decreased. Understood? Okay. Then let us go with when it is diluted by 1000 times. How many times you are diluting? 1000 times. Okay. So let me take pH. pH is equal to 11. So if pH is equal to 11, it is basic solution. We are discussing about the dilution of a base. Then what will be corresponding POH? POH will be equal to 3, because 11 plus 3 is equal to 14. What will be its corresponding OH minus ion concentration? Then that it will be equal to 3 moles per 1 liter. What is that? 10 power minus 3 moles. 10 power minus 3 moles per liter. So this is initial, before dilution. What is OH minus ion concentration after dilution final? 10 power minus 3 moles by, okay, how many times you have diluted it? 1000 times. So 1000 liters. Then what will be this? 10 power minus 6. Okay, 10 power minus 6 moles per liter. So how to calculate POH? POH is equal to minus log 10 power minus 6, and that is equal to plus 6. POH you got. Then how to calculate pH? pH is equal to 14 minus POH, then that is equal to 14 minus 6, that is equal to 8. So final pH is 8, initial pH is 11. How many units it has been decreased? We find a decrease by 3 units. We found a decrease by 3 units on diluting the solution by how many times? 1000 times. On diluting the solution by 1000 times, which solution? Basic solution. We have found that the pH of the solution is decreased by 3 units. Understood? So in the case of basic solution, if you dilute the solution by 10 times, the pH decreases by 1 unit. If you dilute the solution by 100 times, the pH of the solution decreases by 2 units. And if you dilute the solution by 1000 times, the pH of the solution decreases by 3 units. Understood? Okay. So let us see, here is a question given. This is a question given. Among the following, which is correct? On dilution, the pH of an acid increases. Before we have seen pH of an acid increases. Okay. We have discussed that A, option A. Diluting 10 times an acid, pH increases by how many units? 1 unit. This we have proved before. In the same way, diluting 100 times an acid, pH increases by 2 units. So on dilution, the pH of an acid increases. Yes, it is correct. A solution with pH 6 is 1000 times more basic than solution with pH is equal to 3. So let us look into option B. A solution with pH is equal to 6. pH is equal to 6. That means POH is equal to how much? pH plus POH is equal to 14. Then this will be 8. OH minus ion concentration will be 10 power minus 8 molar. Okay. Now another one is given. pH is equal to 3. So let us see, pH is equal to 3. Then POH is equal to how much? 11. OH minus ion concentration is equal to, right, 10 power minus 11 molar. Now you see, 10 power minus 8 is equal to 10 power, okay, 3 into 10 power minus 11. Is it correct or not? This is OH minus ion concentration. This is also OH minus ion concentration. See, 10 power minus 8 m is how many times to that of 10 power minus 11? 1000 times. OH minus ion concentration represents that it is basic in nature, right? Okay. So that is what he has asked. A solution with pH is equal to 6. pH is equal to 6 represents that POH is equal to 8. OH minus ion concentration is equal to 10 power minus 8 molar. So 10 power minus 8 molar is how many times to the top 10 power minus 11 molar? It is 10 power 3 times, 1000 times. Okay. A solution with pH is equal to 6 is 1000 times more basic. More OH minus ion concentration, more basic. That's it. More OH minus ion concentration, more basic. Okay. So this is 1000 times to the top 10 power minus 11. Next, third option, let us see. It is also correct. A solution with pH is equal to 9 is 1000 times more acidic than a solution with pH is equal to 12. Is it correct? C option, let us see. pH is equal to 9. That means H plus ion concentration is equal to 10 power minus 9 molar. Another pH is given. pH is equal to 12. H plus ion concentration is equal to 10 power minus 12 molar. So compare these two H plus ion concentrations. This 10 power minus 9 molar is 10 power 3 into 10 power minus 12. So 10 power minus 9 molar H plus ion concentration is 1000 times to that of 10 power minus 12. So this pH 9 is 1000 times more acidic than solution with pH is equal to 12. So this is 10 power minus 9 molar is 1000 times to that of 10 power minus 12 molar concentration. These what are these 10 power minus 9 and 10 power minus 12? 10 power minus 9 is H plus ion concentration. 10 power minus 12 is also H plus ion concentration. This H plus ion concentration is how many times to that of that H plus ion concentration? 10 power 3 times. So this is also correct option. Okay. Next, coming to D option. The pH of 10 power minus 9 m NaOH is slightly greater than 7. Yes. What is this? Base. Whatever the concentration it is, base will be always base. Base will be always base and its pH will be always greater than 7. So D option, pH of a base is always greater than what? Greater than 7. Understood? So this is also correct. So answer will be all are correct. Understood? Understood? Right? So let us go with the next part. Here is formula given. Here is what? Formula given. So pH final is equal to after dilution. What is this? pH final means pH of solution after dilution. Dilution is nothing but addition water is called as a dilution. If some water is added to a solution, then it gets diluted, and that process is called as what? Dilution of that solution. Hope so understood. Okay, right. So pH final is equal to initial pH plus log V2 by V1. This is final. This is V2 means V final by V initial. V2 is volume of solution after dilution. This is in the case of dilution, no? Okay, volume of solution after dilution, initial volume of the solution is V1. Let us solve a problem. Okay, so what is the formula? pH final is equal to pH initial plus log V final by V initial. Okay, now the pH of a 1 liter solution is 2. So initial pH is 2. It is diluted with water till it becomes 4. So final pH is equal to 4 plus log how many liters of water is added? V final by initial volume is 1 liter. 1 liter. So I can write log V final by 1 is equal to 4 minus 2. Okay. So log V final by 1 is equal to 2. Right. So what will be V final? I can write log V final by 1 is equal to 2 can be written as log 10 power 2. Can I write 2 as log 10 power 2? Log 10 power 2 is equal to 2, right? Log 100. What is log 100? Log 10 power 2 can be written as 2 log 10, that is equal to 2. So log cancel. V final by 1 liter is equal to 10 power 2. So V final is equal to 100 liters. So final volume is equal to 100 liters. initial volume is equal to 1 liter, volume of water added, volume of water added is equal to, volume of water added is equal to V final minus V initial, that is equal to 100 liters minus 1 liter, that is equal to 99 liters. Understood? So 99 liters of water has been added. So this is how we solve by using this formula. Before we have discussed the real concept, here we are discussing how by using formula we can solve it. Understood? Right? So let us see the next part. See here, if the aqueous solution of a base is diluted with water, its pH value decreases. Its pH value decreases. Okay. So this is for a base. Before we have spoken for an acid. For an acid. So pH final is equal to initial final minus your finding is. What is this? Minus. The same V2 means volume of solution after dilution. V1 is volume, initial volume of the solution. Okay. Now let us see this question. 50 ml of H2O is added to 50 ml of barium hydroxide solution. Barium hydroxide solution. See, let us take barium hydroxide solution. Barium hydroxide dissociates into Ba plus 2 plus 2OH minus. 2OH minus. Here, what is its concentration given? 10 power minus 3. 10 power minus 3 m. And looking at the equation, we can find that 1 mole of barium hydroxide gives you 2 moles of OH minus. So 10 power minus 3 molar gives you here 2 into 10 power minus 3 molar. So now we have got barium hydroxide that is OH minus ion concentration. We know that POH is equal to minus log OH minus ion concentration, that is equal to minus log 2 into 10 power minus 3, and substituting what you get 3 minus log 2, that is equal to 3 minus log 2 is 0.6 0.3010. How much? 0.3010, that is equal to 2.6990. We got what? POH. What did we get? We got POH. Then we know that pH plus POH is equal to 14. So what will be pH? pH is equal to 14 minus POH. POH is 2.6990. That is equal to 11.3010. So we have pH, initial pH. Initial pH of the solution is 11.3010. So pH final is equal to pH initial minus log V final by V initial. Okay. So pH final is equal to pH initial is 11.3010. Okay, minus log V final. See, there is barium hydroxide solution. Initially 50 ml is there. Barium hydroxide. Now to this 50 ml of water is added. 50 ml of water is added. Okay. So initial volume initial is 50 ml. Volume final is, after adding 50 ml, it has become 100 ml. 50 plus 50. So what I can write now? 100 by 50. So 11.3010 minus log, okay, 2. So 11.3010 minus log 2 is 0.3010. So the answer will be 11. So pH 5. So are you seeing answer 11? Yes. Yes. Understood. So this is how to solve problems when a solution is diluted. When a solution is diluted, whether an acidic solution is diluted or a basic solution is diluted, by using the formula. Hope so you understood very well. Here each and every step is explained, each and every point is detailedly explained. Follow it very carefully so that you can understand. This is physical chemistry. We have mathematical operations here. You need to pay concentration. Whenever you are watching video, you better go take a pen, put it on the paper, practice. Without that, you won't get it. So follow the instructions, then you can get success, right? Thank you for watching. We shall meet in another class with a new topic. That means in another class, we shall continue with the continuation of this, how to calculate the pH value for a mixture of solutions in the next topic, right? Let's meet in the topic where we will find how to calculate the pH of a mixture of two solutions, acid or base or acid and a base, right? That will be more interesting. Thank you. We shall meet again.